Hello everyone, so my name is on the screen and I would like to thank you for being with me for this session because it's the last session of the last day of the conference and it will be with a strong French accent, so I apologize in advance about that. I will do my best to show you how ClrMD could save you a lot of hours of work. So let's start. First, this is the agenda of the session, and I have a quick question for you. How many of you have used ClrMD already? So very few. Okay. So for those of you who have used ClrMD, I hope you will learn a few tips and tricks and some stuff that will help you for your further investigation. For the rest of you, I think and I hope that you will see that this thing could help you a lot. So let's start with a quick introduction about when you should use ClrMD. I'm working in a team where we are doing a lot of investigation, and usually we are following these like 3 steps. We first start by trying to identify where the problem is by using metrics, and from that we start the investigation. We try to understand what's going on. Where is the problem? And then when we have done that, we have a kind of assumption. We think that might be the problem. And then we are following the last step, which is we try to verify if the assumption is right or wrong. And for each of these steps, we are using different tools. We are using profilers, memory profilers, CPU profilers. And if we are not really lucky, the problem is working or is happening on production servers. And you are not allowed, at least in my company, to debug live or stop anything on a production server. If you are working with customers, for example, you can't go to the machine of the customers. And you usually end up using a tool like procdump to take a memory snapshot of the process that has the problem, and then you get back the memory snapshot, the file, and you start to do the investigation with the perfect tool like WinDbg. I know that Kevin did a presentation earlier today to show that WinDbg could be extended and make it a little bit more humanable and usable. But you start opening this tool, typing cryptic commands and trying to figure out what's going on in the memory. And usually this is something that is painful, and not only for the tool itself, but when you have multi-gigabytes of memory to analyze, it just doesn't scale. You can't do it by hand just on your own. And this is where ClrMD comes into the picture. So what it does, ClrMD is something that helps you write your analysis in C#. So that's something that I hope you like. I think it's a .NET conference, so you like to write stuff in C#. And it allows you to either attach to a live process or work on a memory dump. And from this stage, you can analyze what's inside the process and what's going on. And really, I don't like the animation, but sky will be your limit, because whatever you can imagine, you will be able to do it with ClrMD. And I want to show you a quick example of what you can get with ClrMD. I have written a tiny application, so I'm very good at UI, as you can tell. I hope you can see this. It's a tiny application. Okay, so the Zoom is not working. The demo will be nice. So I get the process ID, which is 11444, and what it does, it allocates strings, allocate timers, and trigger timers, all that stuff. So this will be my scenario. And from this tiny application, I'm also writing a tool in WPF. You can see that the UI is even better than the previous one. And the idea is when you are doing an investigation, often you are doing the same kind of investigation. What I want to say is, when you are doing your assumptions, you can imagine you say, okay, maybe it's a problem with the memory, maybe it's a problem with the CPU, maybe it's a problem with timers, maybe it's a problem with strings. Once you've already did this kind of investigation, you don't want to do it again and again. So what I have done, I have written this nice WPF application that allows me to take a file, a dump file, so it's a memory dump of this application, and I can open it, and I have a few analyzers, so what I'm calling analyzers. Okay, you can see that my icons are as good as the rest, but by the way, the source code of these tools and the rest that you will see today is available right now on GitHub. If you're looking for my name on GitHub, you will have the debugging extensions, and all the source code is available for you. So what I did is I'm having the same analysis, and I can just click on a button. So I want to know if in my application I have too much memory taken by duplicated strings. So what I can do is just click on the strings, and I will get a summary of all the strings that are inside my application sorted by size. So I know that I have like 5K of this string, but only 24 instances. This one is 129, so just for a demo. But you can see that very easily I can figure out if it could be a plausible assumption that my problem comes from duplicated strings or not. You can do the same for. So here you will see the kind of investigation I was. If you have problem with threadings, you can get the list of the threads. You can have information about thread pools, about timers. And if you need to dig into the CLR itself to understand how things are working, you can also do it. So here it's an example about a problem that we had with the usage of the garbage collector. So what I've written with my friend Kevin is a tiny UI. So this time is a little bit nicer UI. If the zoom is working, that's fine. So if you take a look at just this on the screen, and I'm telling you that this is the layout of the memory of the process. So I have 4 segments. I have one for generation 0, generation 1, generation 2, and the large object heap on the top. So very visually, I have tried to show the percentage of each generation. So you can see that everything almost is in generation 1 because the blue is the size of my segments. And in white, it's the free space. So we can start to talk about fragmentation, if we can say, because we have a lot of empty space in generation 1. And what's in the tiny red lines, vertical red lines, we had some problem with pinned object. Because when you do some asynchronous IOs, you end up having some memory that is pinned inside the memory of your application, and it's the red dot. And we have understood that some of the optimization, some of the decision made by the garbage collection to decide when it should shrink some of the generation, some of the segment, was also impacted by these red lines that we have. If it's at the end of the segment, then it could forbid for the GC to release all the memory. So you can see that very visually, you can understand what's going on. So this was the limitation of my imagination for now. Okay, so let's go to the details. ClrMD is a nickname for the Nugget package provided by Microsoft, the Microsoft.diagnostics.runtime package. The source code is available on GitHub, and you also have a lot of samples. So just spend a few seconds over there. So you go to the Microsoft ClrMD on GitHub, and you get access to the source code. So you can go there. What is interesting is the fact that you have a few samples, very simple sample from here. And if you click on the sample link here, you have more advanced samples. For example, the CLR stack sample is a sample that is interesting in our case because I'm working with other people in our team who are working on the Java side of the story. So when something goes wrong on Java application, the guy gets called. And so we had some discussion to trying to understand what is possible with the Java runtime, what is possible with the .NET runtime, the tooling, and all that stuff. And we, during one of the discussion, the guy told me, you know, it's very easy in Java. It's implemented that you can ask like this, and you get the list of all the threads and the call stack for all the threads of any running Java application. I was like, We don't have that in .NET, it's not built in. But with ClrMD, you can build it, and you have the samples as an example. So just to show you that it's really something that could help you. And my point at the beginning when I'm saying that you can use Profiler and all that stuff in WinDbg, it's sometimes easier to write your own tool that is really tailored and customized for your investigation. And these samples are a good starting point. The source code of ClrMD is available, and I think you should take the time when you are doing an investigation on a specific space like threads, threadpool, memory. Take a look at how ClrMD itself is implemented. It will give you good patterns in terms of performance of how you should use ClrMD. So let's enter ClrMD. So ClrMD gives you an object model to dig into the internals of the CLR of your application. So the entry point is the data target type. The data target type is the first type that you can get in two scenarios. You can see the methods at the bottom. You have the attach to process to attach to the live process scenario, and you have the load crash dump, which is the other spectrum. When you have a memory file, a file of the memory snapshot, you want to load it. And from that time, both functions are returning a data target. So that's the basic. Once you have the data target, what you can do, the first thing which is interesting is the architecture. Do you want to know if it's on AMD, if it's x86, ARM? But the thing which is very important for you to remember right now is the pointer size. You could see pointer size, it's very low-level information, but no, it's very important to understand that when you are dealing with an application or a memory dump, the bitness of the memory dump or the application must match exactly the bitness of your own tool. So the tool that I will be building are either in 64-bit or in 32 bits, and they will be able to load either a 64-bit or a 32-bit. So how do you know that? You know that because the pointer size. If the pointer size is 4, you will be dealing with 32 bits, and if it's 8, it will be 64-bit. So once you loaded the data target, the first thing you need to do is check for the pointer size and ensure that you have the same bitness. Okay? So usually, if you are to deal with application in both 32-bit or 64-bit, you need to build two tools, two versions of your tools. Then, what do we have now? We have the last method that I didn't mention, the enumerate module method. This enumerate module method gives you the list of all the DLLs and assemblies loaded in your process, both the native one and the managed one. You will see that we can get almost the same kind of list after that. I will talk about the symbol locator in the next slide. So we have the data target. From the data target, we get more information by going to the CLR version property. The CLR version property gives you a list of CLR info. I don't know why they pick CLR version if it's a CLR info, but why do we get a list? Because since version 4 of the CLR, due to problems encountered by applications like Word that supported a plugin mechanism, they wanted to be able to have in the same process two versions of the CLR. One version 1 and 1.1 for the old plugins, and one started from 2 up to where we are now. So that's why we have a list of CLR info, but in our case, usually in our days, we don't have to support this kind of scenario. So you take the first one in the list, and you get the CLR info. Once you get the CLR info, it started to getting not so interesting, in fact. What is interesting for you? Maybe it's the version property, the last property in the slide, because it gives you in which version you are running, 4.7.3, for example. Once you get there, what you want to do is get a CLR runtime. You want to get a CLR runtime, you will see the CLR runtime is the real pile of information from which you will start. But before doing it, you have to do something related to the implementation detail. when you install the .NET framework on a machine, you install everything, the CLR and so on, and you install two files. You install sos.dll and mscordacwks.dll. SOS is the plugin that is used in WinDbg when you need to go into the CLR, and SOS is the upper layer. The data model is exposed by mscordacwks.dll. And ClrMD is using both. So you need to set up ClrMD to say, okay, you know, I need to find these two DLLs, and I will give you the path where you should find these DLLs. So to do so, you need to set up the symbol locator property from the data target that I've shown you earlier, and you pass a syntax that is very close to the syntax you would use in WinDbg, which is you define like asrv, a star, and you have the symbols just over there. Maybe I can, yeah, it's not working. It was working yesterday. The gods are against me. But anyway, here, you can see you have like a local cache, because it's much faster if you can just download the PDB and the DLL once, and then if you are investigating more and more, you don't have to download them again and again. So the first one is the local path, and the second one is the name of the HTTP endpoint provided by Microsoft that ClrMD will use to automatically download all the PDBs and the two DLLs I mentioned. Once you have set up that, you can call create runtime. And then you end up in this entry point of all the feature. So I don't want to spend too much time here, but just to make you understand at which level you are reaching now. You have the list of the app domains. If you have app domains, we will see in a moment that it's important for static values. You also have the heap. I won't dig into the heap now because most of the rest of the session will be dedicated to the heap management. And then you have, again, a modules property that returns a list of modules, of CLR module, and this property returns only the managed assembly. And we'll see that there is some difference between the one that you would get from the data target and the one we'll get here. Again, the pointer size, don't ask me why you get the pointer size is, because it's too late. Usually you have crashed before. The server GC, if it returns true, you know you are running the garbage collector in the server GC mode. Otherwise, it's the workstation mode. You get the threadpool that gives you plenty of information about the threadpool. Same for the threads and the list of threads. You can have even advanced information. When I'm saying advanced, like everything related to finalizers. For those of you who are doing some COM interrupt, you have some information about the COM callable wrapper called the CCW. Really deep, okay? You can even get information about delegates. If you get the address of a delegate, you can get a CLR method that wraps the information to get the signature, the type, even the IL, whatever you want. But the thing that you usually want to do is to get more information about the heap itself. But before that, I want to spend some time leaving the slides, because slides are good, but usually you start to sleep in front of slides. So let's go to an application that I will write with you. So is it big enough or big enough? It's enough? Okay. So this is a console application, and what it will do, it will support the two scenarios I mentioned already, either attaching to a live process or loading a memory dump. So I'm expecting a parameter on the command line. It will be either an int. If it's an int, I'm expecting it's a process ID, and I will try to attach to a live process. And if it's not an int, I'm expecting it's a file name. If the file name exists, maybe it's a memory dump, and I'm calling these functions to load the memory dump. And starting from that, it should work. So again, don't forget to add to your project the Nugget package. So here I have the Microsoft.diagnostic.runtime, and once we have done, we can start to write some code. So since we are just a 1 hour session and it's the last of the day, I didn't take any chance to write the code by myself. It would be much faster to do something like this and have a code snippet. So this code shows you the code to write to attach to a live process. If you remember the slides, what I have to do, I will have to call the attach to process with the process ID. And then I will get the data target corresponding to the process. But before that, I need to set up the symbols. All the trick with the property to give the path where the SOS and mscordec wks.dll will be loaded. I will show you that in a moment. But you can imagine that if I want to write some code to do the same with a memory dump file, then I will have almost exactly the same, which is I'm calling this API instead of the other one. I get the data target. Before that, I have set up the symbols, and I get the data target. And both cases, if you take a look at these codes and this one, they're both ending up calling the same functions. What I want to show you now is, once you've written this boilerplate just to bootstrap the initialization, after that, once you get the CLR runtime, you will have to write the same code once. Okay? It will be the same code either for a live process or a memory dump. So where is my code to set up the symbols? Very quick, it's exactly the same code that I've shown you. I mean, you can imagine. So I'm checking if I have my local folder to get the symbols. If I don't have the folder, I'm creating it, and then I'm setting up the string corresponding to the one I've shown you in the slides. And I'm setting up the symbol path on the data target over there. Okay, so right now, we have all the boilerplate code. You write it just once, okay? Believe me, you have a base class, you write everything in your base class, and after that, you just forget it. And we can start to analyze. So what I will do, I will try to get the bitness of the application, get the version, and get the list of all the loaded DLLs and assemblies. Here, I'm protecting my code with a catch exception. I know that if Jeff Rector was in the room, he would have already thrown potatoes to me, because this is not the thing you should write in your production code, okay? This is bad. However, since you are writing a debugging tool that might end up opening a memory dump that might be corrupted in some ways, ClrMD might behave in a very, very weird ways. So it's a good habit when you start to use ClrMD to write this kind of code, and then you can get the list of the exceptions that you will have to check in your own code, and that way you will learn what kind of problem you can end up with. So, how to get the bitness? It should be easy. We get the CLR runtime from the target, but first we check the architecture, and we check based on the pointer size if it's a 32-bit or a 64-bit. In my case, my application is a 64-bit application, okay? And the running application is a 64-bit application, so it should work fine. But anyway, you need to check that it's good. From that point, you can create the runtime, you get the CLR runtime, and you can get the version both for the target, so both for the target, or from the CLR runtime. Easy. Then how to get the list of loaded assemblies. I will give you the two ways to get the loaded assemblies. You will have one way from the data target, because from the CLR runtime, you can get back to the data target. It's a way to get the lower level information. And from them, I'm calling the enumerate modules. I'm checking that I just want the manage assemblies. I don't care about all the native DLLs. But if you are interested in the native DLLs, you can check it. And I will add a tiny code here, because I don't want to have the two lines that will be at the same place. So just to make a difference, like this. And the second way to get the modules is to use the modules property from the CLR runtime itself. Okay, let's run the code. I'm print the assembly name. Let's run the code. Oh, something I should have shown you, because otherwise you might think that I will be cheating. How do I test that? I have the property of my application, and I'm passing the process ID, which is 11444. Remember, it's the process ID here, which is 11444. Okay, I'm not cheating, it's the same application. So let's see what we got. We got something which is too small. Is it better? Is it better? Enough? Enough? Okay. So what you can see here, we have, my machine is an AMD 64. It's a 64-bit machine. And I'm running the version 4.7.3. And I get two lists of modules. And if you take a look at the first list and the second list, the names are almost the same. They look like the same, but the path is completely different. And maybe even the extension is different. So what's the difference between the two lists? The one that is the most useful usually for you is the first one. The first one gives you the real DLLs that have been loaded into your process. Why could it be useful? It could be useful because sometime on production server, you want to ensure that you have the exact right version of the file you think you have on the server. And that way, you could validate that it's really the one that you think you have running on the server. The second list is the list that I would say match the dependencies you have expressed in Visual Studio, for example. And if you have loaded your assembly, your program with a decompiler and look at the dependencies, you would have this kind of information. There is not the exact version, it's the version 4, but we don't really know which exact version, and you get the name of all the DLLs. So usually, it's the first list that is interesting for us. Okay, so you see, we start to get something with ClrMD. Most of the API is really object-oriented. It's an object model, and the name of the class, the name of the property is pretty clear. But I want to spend some time with you on the part of the object model related to the memory and how the CLR is managing the heap. So let's go there. From the runtime, you have a property called heap that returns a CLR heap. The first property, again, is very important. Remember the pointer size? Why is that important? Here, the can walk heap property is very important for you. Why? Because if you are not lucky, the application you are investigating right now, or the memory dump when it was taken, the garbage collection was occurring at that time. So at that time, the CLR, the garbage collection, is moving objects around, changing referencing, and also. So in that stage, the heap is not browsable. You can't iterate on the element of the heap. So you need to check that can walk heap return true. If it doesn't return true, too bad for you. You have to attach again to the process or ask your customers to take another memory dump because you can't do anything there. Then, from that, you have plenty of information. I don't want to spend a lot of time here. I've used some of them to get the segment. Remember my WPF application with the segments, Gen 0, Gen 1, Gen 2. You get this information from mostly there. But the thing that you want usually to do with this kind of memory dump or application is, okay, I want to know where are my instances? What are the relationships between my instances? What are the roots? And so I will show you that mostly you have to use two functions. So the kind of code that you will write is a code like this. You call from the heap the enumerate object addresses. For each of the addresses that match an object in the live process or in the memory dump, you ask the type that matched the object. Have you done some reflection in the room? Who in the room has done some reflection in a C#? Okay, okay, good. That's good. So in reflection, it's almost the same pattern, okay? You get some type info, you get some field info that helps you dig into the information. It's almost the same. You get an address. If you think about it, the address that you get is the address from a remote process. So Jeffrey Richter mentioned earlier that the processes are like isolated. The value of an address there and there and there, even if it's the same address, it's just meaningless between processes. So think about that. So we get the type corresponding to the object. From the type, we ask for the value. If my mouse wants to work. Okay, not working. So here, once I get the type, I'm asking to get the object that is at that address with this type. Please, ClrMD, give me, marshal for me, the object here. And once I'm there, I can start to do some investigation. Okay, remember my catch exception there, because sometimes, yeah, and some invalid exception might occur sometimes. Don't ask me. Sometimes I get this kind of exception. But anyway, what I want to show you now is how to use this kind of code to write the string duplicate code that I've shown you in the demo. Let's go back to my Scratchpad. Let's see, where am I? I have my analyze application, and I don't want the list anymore. And I want to list the strings. So this part of the code is really not interesting at all. It's link queue just to sort everything. I don't really care about that. Believe me, it gives you the list sorted and grouped by the size. What is interesting is this function, the compute duplicated strings. What it returns, it's a dictionary where the keys are the strings with different values, and the number is an int, which is the number of string with this value. So let's see this code, what it looks like. If you take a look at the code, it's almost a copy and paste of the slide. So I'm creating a dictionary of string. I know that I have a lot of strings, so I always set the capacity at the top, like a millions of string. Who knows? We have big memory dumps. The second line is doing the check. Remember, always check that. If it's true, too bad. Return null, I can't do anything for you. And from here, it's the exact same code that I have taken from my slide. And from there, what you are usually doing is here. What you want to do is, okay, if I'm a string, so if I'm a string, if the name of the type I get from the address and from the remote, okay, memory dump, live application, if it's a string, then I can try to do something. I can ask for the value, which means that I want ClrMD to marshal the string for me, because the string is there is nothing here. And once I get the string, okay, I'm just checking if it's not already in my dictionary. You know, the way the dictionary is doing the string comparison allows me to do this kind of shortcut. So I'm relying on the string comparison of the dictionary. And what I'm doing, I'm just saying that, okay, I find one instance more of this string, the foo, the bar. I will have two values, but maybe I have many strings with the same value. So it's quite simple. Okay, if we go back here, we could say, okay, Chris, it's the end of the day. We love your French accent, but we would prefer to go to our laptop and check, download everything, and do ourselves. I would say, okay, fair with this, but I want to show you that there are tiny problems. The first one is the fact that I forgot to mention that the magical marshalling that ClrMD is doing for you, taking the string here, bringing it back to your tool, from here back to your tool, well, it's working only for booleans, numbers, and strings. So what does it mean? It means that if in your type you have a field that is a reference to another type that has fields, not only Boolean, numbers, and string, but a reference to another, you will have to marshal each and every object by hand and get the value of each and every property by hand. This is not very funny. So let's take an example. Okay? Right now, everything was shiny, strongly typed object model, life is good. Let's take an example. So, how many of you have watched the recording of the session that we did with my colleague Kevin in St. Petersburg? A few. Okay. For the rest of you, there is a recording of the session where we had a problem with the timers. And if you want to have the whole story of the investigation, I recommend that you take a look at the recording. But what I want to show you here is, during this investigation, we needed to get the list of all the timers. And so we take a look at the implementation. And the implementation of the timer is simple. When you create a timer, you provide a delegate, you provide information like the time you want it to start, if there is any period to do some repetition. The base class library is taking this information, storing them into a timer queue timer, and list through a linked list all the timer queue timer corresponding to each and every timers that you have created. This list is pointing to, it started by this s_q static field from the timer queue type, and the instance of this s_q has a field called m_timers that points to the first of the list. So I want to iterate on the list. And what I want to show you now is how you could do this with ClrMD, because this is something that you will usually have to do. So first, you need to get the type corresponding to the timer queue, again, very close to the reflection kind of API. Once you get the type, you need to get the description of the static field info. Once you get the static field, you read the value of this static field. Then, once you get the value, you need the value of the instance field, the m_timer. This tiny, if my story wants to work, this tiny here. And once you get that, you have to read each and every properties on a timer queue timer. Go up to the end, m_next, go to the next. Do the same until the m_next equal 0 or null. So how would you write this? First, you need to access to the static field. And I found this in the implementation of ClrMD. This is why I'm telling you that sometimes it's interesting to see how they have done their own implementation. Basically, what I'm doing here, I know that the implementation of the system.threading.timerqueue is in the mscorelib.dll. So I'm looking for this specific DLL in the list of the module. And once I get the module, I can ask for the type by calling the getType by name. It's much faster than using the getType method from the CLR runtime, much, much faster. So here, I get the type corresponding to the class that contains the static field. So there is a difference between a static field and an instance field. In .NET, not in .NET Core, but in .NET, one process can have several app domains. Okay? You can imagine like an app domain is like a container in which one application is running inside one process, Win32 process. And one of the rules is that each app domain might use a type with a static field. And the value of the static field is different between each and every app domain. So you need to first list the app domain. And for each app domain, when there is a value here, because usually it's the just-in-time compiler that does all the initialization of the static fields. And if in the app domain none of the code has already used this static field, it won't be initialized. So that's when I'm doing some testing about if there is a value or something like this. So after that step, I have the value corresponding of the address of my instance. And what I want to get from this instance, this static stuff, is the value of its m_timer property. This time it's not a static property. It's an instance property. So what I have to do, I have to write 3 lines of code. So each time I need to get the value of a property, I need to write these 3 lines of code. I need to get the type. I need to get the description of the property based on the name of the property, and then I'm calling getValue. Okay? It starts to get boring. I don't know for you, but it's getting boring. So this is a special case for the delegate. The delegate is a little bit more complicated. Why? Because you have 2 pieces of information for a delegate. The first one is the pointer to the method that you want to be called by the timer in my case. So this one is given by the underscore method PTR. And you can use an API, the get method by address, that give you the description of the method. I already mentioned you get the IL, the name, the signature, everything. If the delegate points to a static method, you don't care about the this pointer. You remember the difference between a static and an instance? The instance method gets an implicit this parameter, and the this parameter is stored in the underscore target field of the delegate. So that way, you would know on which type the function that you get will be called. It's like the this. So that's why I'm trying to get the value of the underscore target. Once you get this, you can get the type, the name of the type, whatever you want. So we are almost done. I want to quickly show you the code. It should be fast. I have skipped something, but maybe I will come back later. Where is my code? Where is my code? I don't remember where I am. Yes, here it is. So this is the code that you will have to write. I won't spend a lot of time because it's exactly the same as in the slides. Blah, 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 the slide, the same. Here it's where it's becoming a little bit different. I'm interested in 4 properties of the timer QTimer. So each time I need to call this code. And the get field value helper function, as you can imagine, contained the 3 lines of code. Get the type, get the description of the field based on the name, and get the value stored in the field. It's not really the kind of code that I would say a la C#, okay? This is not really what I'm very interested in. So what I want to show you now is that ClrMD is nice, but the syntax is a little bit complicated, okay? Always have to write this kind of code just to get the value of 1 property. Imagine if you have 10 properties in your object, it's just, I don't want that. What if I could write it a la C#, meaning I want the value of the field name value, I just want to get the address, get some magic down underneath, and I'm calling dot value. That would be great. Again, if I have some arrays, I want to iterate on each and every element. I have to do it by hand. If there is some instances that implement the iteration, I want to use my for each and a for an array. I can't do that. I have to do it by hand. And if I want to get only the instances of timers or only the instances of string, I don't want to have this loop that check for the type and then get the value and so on. If I could get only the strings, could be very, very helpful. So we had this kind of discussion when we were writing the tool, and Kevin, the guy who did the presentation this morning about the extension of WinDbg, said, okay, I don't like this code. Okay, I want to write C#. I don't want to write scripting about something. So let's try to find a solution. So he ended up writing this DynamD NuGet package, which is free, and you have the source code on GitHub. All the links will be provided at the end of the presentation. So with this stuff, what it's doing is leveraging the dynamic keyword. What it means, it implements a class that inherits from a dynamic object, override the right functions. If you are interested in this kind of thing, this kind of magic, believe me, it's really, really interesting. Just take a look at the implementation, and you will discover very, very nice stuff. So what I'm expecting now is, instead of writing the code that I've showed you, once I get the address, I'm asking to get a proxy, something that looks like a real object to me, but the responsibility of this proxy is do all the marshalling for me. So I have an extension method called getProxy on the heap, and now if I want to get the m_bucket field of the m_table field of an object, I write the code in the middle, which is something that I definitely want to write instead of the other one. It supports for each for enumerable, it supports for arrays, and I even get another extension method called getProxies with the name of the type, and I only get the instance in my whole heap for that type. Very, very handy. So let's take a look at the code that I would write with DynamD. Let's see if I have something like this. I don't know if it's the screen will be large enough. I don't know. But anyway, this is the same code. So you remember this? Bah. Take a look at this one now. Oh. This is what I want. Okay? Once I get the address, everything is done magically for me. Okay? So from there, it should be good and starting to say that, okay, that's something that I want to use. So I want to spend some time talking about something I skipped earlier, and I'm sorry about that. I mentioned that you have the source code of ClrMD. So when I started to do all this investigation, and I was wondering why I couldn't get any information from a remote instance other than a Boolean, a number, and a string, I tried to debug all that stuff. And it's at the end of the day, you're ending up in this function. And the function is called getValueAtAddress. So this is the internal representation of a type that it extracts from the CLR type. You get the address. And if you take a look, it's just, okay, guys, if it's a string, let's marshal a string. And if you take a look at the implementation, what it does, basically know how the string is implemented. So you know there is a first char, the string length, and blah, blah. And then it starts to decode by hand each and every character, one by one. So it does the job for me. That's very nice. If I'm going back here, skipping this one, Boolean, it's reading the byte. If the byte is 0, it means false. If it's not 0, it means true. And so on with the numbers, int, 64, pointers, it's just the address, int 8, float, whatever you can imagine. But the thing that was left at the very, very top of the function is this kind of code. So if you think about that, what it does for a class, an array, a Z array, and an object, it gives you the address. You have an address that contains a reference to something. It will give you the address of this something. So you end up with another address which is not marshal at all for you. And this is why you need to do all the marshalling by hand. But DynamD is doing the marshalling for you now, so you don't really care. But just to let you know that you can understand what's really, really going on. So where am I now? Okay, so how many of you are using WinDbg? A few. Okay, so WinDbg is a native debugger, the Windows debugger, that you can use to analyze .NET application, .NET memory dump. But WinDbg knows nothing about .NET, okay? It's the SOS extensions that allows you to dig into your processes. So it means that WinDbg supports an extension model, which is native. What it means that if you want to write an extension to WinDbg, not the kind of very fancy extension that Kevin showed you earlier with UI and all that stuff. I'm meaning the extension that you will type some cryptic command, the more cryptic you can imagine, okay? This kind of extension. So what you need to do, you need to create a native DLL. In a native DLL, you exposed functions, and the name of the functions are understood by WinDbg as the name of the commands. So the name of the function equals the name of the command. You have to copy that in a certain area on your disk, and you can load them by a .load with the path, or if you don't give the path, if it's in a certain WinNext subfolder, it will be loaded for you. And after that, you can type your cryptic commands, and it will run. So my idea is, I'm spending a lot of time in WinDbg, and I want to have the power of ClrMD inside WinDbg, because when I'm starting a new investigation, I don't know what's going on. I have already checked all the strings, all the timers, and all that stuff. And sometimes I want to have the same power inside WinDbg while I'm debugging a problem. So I want to have the same code that I have already written in my nice WPF application, but inside WinDbg. So I need to create a native DLL. And I'm using for that the unmanaged export nugget that you can find. And what this nugget does when you add it into your project, it changes the build of your project. So your project will be an assembly with some function that you will export, and you will decorate your method, your static method, with the DLL export attribute. The signature of your method must follow the signature that I've listed here. The first parameter received an int ptr, like a void star, like C. It will be the pointer to an interface provided by WinDbg. And I will show you what ClrMD will do with this. The second parameter is a string. Why do you get a string in a command? Because you want to be able to accept some parameters after your command. If you have used SOS, and one of the commands that we are using a lot is dumpheap, you will almost all the time type dumpheap minus stat. And you want to know the parameters, and this is where you get the argument as one string. So all your functions will have the same signature. Then you copy everything. You build, you copy your extension, your DLL, and you also copy with it all the references that you need. You will need ClrMD, you will need DNAMD if you use DNAMD. If you don't use DNAMD, don't complain that it's harder than with DNAMD, and all the rest of the references. And once this is done, you can just .load your extension. So let's talk about the magic that's going on here. There is an example provided by ClrMD in the samples, which is called WinDbgX, and you need to copy one file, just one file, called common.cs from this example. You get this file, you copy it in your project, and it will define a type, and you will extend this type. So once this is done, the code that is written in this file will do some magic. So I try to list a little bit what it does. The first thing you need to, I didn't write it here, but it bootstraps the CLR, because WinDbg is a native application. It knows nothing about the CLR. It will bootstrap the CLR. It's scary. So it will bootstrap the CLR before any of your managed code will try to run. After that, it will register to the CLR about the event that is raised when it looks for types that it's not in the current assembly. Remember, I mentioned that you need to copy all the dependencies in the same folder. That's my convention. That's my convention. You can have your convention, but that's mine. So I have to write a tiny piece of code to look for the assemblies that I will get from the event. Oh, I'm looking for DNAMD, where it is. I will look at the same place where my assembly is, look in the same folder, and return the assembly. The second thing is very implementation. It's the debug extension initialize method. It's something that is called for every extension, provides some versioning. We don't really care. We'll never see it again. The last part is something that puzzles me at the beginning, because I was thinking, okay, I will write my code in C#, magically it will run inside WinDbg, but how can I send information to WinDbg? I don't get any interface, nothing. I get an int ptr, if you remember. So what this thing does, he says, okay, guys, if you want to send something to WinDbg, it will be text, because you are creating encrypted commands. So the answer of the cryptic command, the response, will be text. So we said, okay, let's reroute all the string that you will send to console. So if you type console.writeLine, instead of going to the console, it will go to WinDbg. And this part of the magic is done for you by the command.cs file. And after that, you write your function in another file that extends the partial class debugger extension. And in all of your function, you just call init API. And that's it. Cool. Let's see if I'm telling the truth or I'm lying. So let's start with this extension. Again, all this code is on GitHub and everything is available. So since I've been using WinDbg for a long time, I know that usually I have commands with a long name and with a short name. So this one is the file dedicated to compute the string duplicates. So I have one command which is string duplicates. Everything is in lowercase. Here you have a kind of camel case. And for the lazy guys, for the smart guys, the guy who remember the cryptic, just have SD, faster. But all of these functions are sharing the same signature. So they have the same signature, remember, an int.ptr arguments, and each and every are decorated by the name of the functions that will be exported as the native word. And they all call the same function, which is onString duplicate. Remember, one thing you need to remember, call init API. Once init API is called, you can use the runtime property that is provided by the command.cs file, and this is a CLR runtime. You get the heap, and this code is the same as the one that I've already written. So I can share the same code between my console application, WPF application, WinDbg extension. Okay? So I have like 4 minutes left, so I just want to take a few minutes to show you the part of the magic. The init API is doing the magic. So the int.ptr proper here, what you get in the signature, this one, it's not a void star. It's a pointer to the iDebug client interface that is exposed by WinDbg. And we are very lucky because the guy who, Lee Culver, who implemented ClrMD said, okay, maybe I'm crazy enough and I know how to convert this iDebug client into a data target. Woohoo! So from there, this is where most of the magic, how to use ClrMD in WinDbg, okay? Because you don't have access to the live process or to the dump file. It's through this interface. And so from there, this function is called, does everything, and you get a data target. From the data target, you get the runtime. If there is no runtime, then I'm just getting the runtime. And that's it. The runtime is here, and everything works. This is where, if you are interested about the redirection of the console, it's in this function. I don't want to spend some time here, but it's done for you. Okay. So this is what I've done. This is the resources for you. I've written a blog series of 9 posts where you get each and every detail of the part of the ClrMD. Please take a look at this. You have the link to the debugging extension. You have the link to ClrMD on GitHub, and you have the link of DynamD on GitHub. I think with this, you can feel confident to imagine what you can do with ClrMD and how it could help you. Thank you very much for your time.